These are Advanced Math Notes, Unit 8, Lesson 7B. All right, you should have this handout that was given to you in class. If you didn't get one or you've lost yours, you can always print it off. It's on my website. You can go through and read this on your own. All of this is what was in our notes from Lesson 7A. Okay, so you can read that on your own. Examples, find the inverse of f and then sketch f and f inverse. So this is where we're actually going to start graphing. Okay, we know how to find the inverse already. We swap the variables. I'm sorry, you put y in for f of x and then you swap your variables. So you change f of x to y, flip-flop your x and y, and then solve for y. So add your 1, divide your 2. Go ahead and do that now. Add your 1, divide by 2. I end up with y equals x plus 1 over 2. And I am going to, when I write it as an inverse, f inverse of x equals, I'm going to write it as 1/2 x plus 1/2. 1/2 x plus 1/2. I'm writing it like that because I want it to be in y equals mx plus b form, so it's easy to graph. All right, there's f of x, there's its inverse, and we're going to graph. First thing I'm going to do is draw my y equals x line. Remember, your y equals x line goes through the origin from corner to corner, like that. That's y equals x. Remember, your y equals x line has a y-intercept of 0, so it's at the origin, a slope of 1, up 1 over 1. If you just keep doing that, you go from corner to corner. That's your y equals x line. Okay, I graphed that in to show that the two lines are going to be reflective across this diagonal. Okay, first one, y equals 2x minus 1. So we go down 1 and a slope of 2, up 2 over 1. I think I will do that in color. I go down 1 and a slope of 2, up 2 over 1, up 2 over 1. And I just do it a few times just to make sure that I have a nice straight line and I'm not going off anywhere. Again, if you have a ruler, you can use it. If not, just do the best you can. And I kind of went too far down there. This is f of x. And now I'm going to draw f inverse, which has a y-intercept of positive 1/2, and a slope of 1/2. So positive 0.5 is in between 0 and 1. And then from there, I'm going to go up 1 over 2. Now from a half mark to a half mark, that's up 1 over 2, up 1 over 2, up 1 over 2. I'm even going to go down 1 over 2. Okay, so remember, when you're going up 1, you go from one half mark to the other. So you're going to stay at the half marks. And you can see that it is symmetrical around the penciled y equals x. If you were to fold your paper right on this pencil line, these two graphs would line up on top of each other. All right, f of x, and this is the inverse function of f. All right, I am going to cross out this one. And we are going to do number 3. I don't want to make the notes too long. This is another line just like this one, so I'm going to skip it and do some non-linear graphs. Okay, here's the original f of x. Go ahead and hit pause and find the inverse. Hit play and see if you have the same answer I do. Y equals the cube root of x minus 1. I'm going to write it as f inverse of x equals the cube root of x minus 1. f inverse of x equals the cube root of x minus 1. Okay, this now is going to require you to use your tools from last year on how to draw your parent functions and translations. X cubed is the one that looks like the tangent graph, kind of like that. That's actually the positive x cubed. Remember, the plus 1 that's not in parentheses is your translation that goes up or down. So this goes up 1. So the point goes up 1, and then it looks, actually, I'm going to draw my y equals x line first. You do not need to draw the dots in there. I do just to help line up my ruler, but as long as you go from one corner to the other, that is your y equals x line. Okay. Up 1, and then it looks like that for your cubic function. Now, if you remember your cube root function, your teacher may have taught you was that Egyptian looking function. Do you guys remember that? So it's the one that's like this on its side. Now, what you remember about translations, if it's inside the parentheses or inside a radical, that's your right-left translation, and it's always opposite, so you're going to go right 1. Do you guys see that? Again, that's last year's notes, last year's lessons, where the translation right and left when it's inside the parentheses or the radical, and it's going to go like this. If it helps, you could hold your paper like this, and it kind of looks like a negative cubic graph. It's up to you and how you want to do it, but that's what it looks like. And again, you can see this is a rough hand sketch. I didn't actually plot points like I did up on that one, but still, if you were to fold your graph on that y equals x line, it should be a mirror image of itself. All right, number 4, go ahead and hit pause, find the inverse, and see if we get the same thing at the end. Okay, I have f inverse equals x squared plus 5. Okay, and I may have to change this in just a little bit. We'll see. Okay, sideways parabolas. Half of a sideways parabola is the original f of x function. And remember, inside the parentheses or the radical is your right-left translation, and it's -5, which means you're going to the right 5. And before I do that, I'm going to go ahead and draw my y equals x line. And I'm going to come back up here and actually label them because I did not. This was f of x, and the blue one was f inverse. Okay, now back to this one. The original is shifting to the right 5. 1, 2, 3, 4, 5. And it is opening, it's the top half opening to the right. You guys remember those from last year, half of a sideways parabola. Okay. This one is a regular parabola opening upward, and the 5 is not in the parentheses, so it is going up. I'm going to call this one f of x. Now this next piece I'm going to write in pencil because I will be erasing. So if you are writing in pen, don't draw everything with me. Up 5, 1, 2, 3, 4, 5. It's opening up. And you can see something's wrong. It's not a mirror image of each other. This has an extra piece. For example, if I cut that off right there, then it would work. Knowing what we know about inverse functions, a function can only have an inverse if it is 1-to-1. This here is a 1-to-1 function, but we've already talked about parabolas. A whole complete parabola is not a 1-to-1. It crosses it twice when you do the horizontal line test, which means we have to erase half of the parabola. Which half? You can pretty much look at it and figure it out. It's going to be the left half to get it to match. If you're not sure, you can find domain and range. Domain here should be 1, 2, 3, 4, 5, 5, comma, infinity. And the range is negative infinity, put a D for domain. Range is negative infinity to 0. And I wrote that down wrong, I apologize. 0 to infinity. 0 to infinity. 0 and it goes up forever, which means it should flip-flop for this one. That one, the domain, should be the range. I'm just going to write it 0 to infinity, and the range should be this one's domain, 5 to infinity. Okay, range 1, 2, 3, 4, 5, infinity, that works. Domain has to be 0 to infinity, which means we have to erase that side. Okay, you don't have to find domain and range for each one. I'm just showing you that's another way of doing it. Keep in mind, if they give you, like say they just give you this graph on the test, and they ask you to find the domain of its inverse, you do not have to go through and find it and graph it. You can, it's not that hard to do. But if they give you this, f of x, and they say find the domain of its inverse, all you have to do is find the range of this one, of the original, and it will match up with the domain of the inverse. And that will always work for inverse functions. We'll talk more about that as we go. All right, that's the f inverse function. All right, flip it over to the back side. The graphs of inverses are reflective mirror images across the line y equals x. We've talked about that already. Sketch the inverse of the following functions on the same graph. Is the inverse a function y or y not? Hint, remember the horizontal line test. Okay, so I'm going to draw my y equals x line. Okay, so I'm going to call this one the original function. And we have to sketch the inverse. Now, eventually it's going to get a little easier, but I will tell you this. Right now, just make a t-chart. And just pick like a few points that you can find on the original graph. For example, that's a point I know that's -2, 0. Like those don't go through corners, but that one right there does, and that is 0, 2. So you're just looking for points that go through corners. It looks like that one does. That's 1, 2, 3, 1, 2, 3. That's 3, 3. That's enough. Now let's do the inverse. I'm going to call this y f of x. So when I do x, this is going to be f inverse. So this is my original function, this is my inverse function, and everything should flip. 0, -2, 2, 0, and 3, 3. Let's plot those points. 0, -2, 2, 0, and 3, 3. And we know that it should curve like that, but going upward, oh. And there is my f inverse function. All right, makes sense? Okay, so again, when they don't give you a function that you can work with, t-chart it, flip them around, plot them, and you should end up with your inverse function. All right, next one. T-chart x, f of x, -4, 1, -5, 2, and it looks like there's also a -3, 2. 1, 2, 3, up 2. Okay, x and f inverse, so you flip them all, 1, -4, 2, -5, and 2, -3. Okay. 1, negative 4, 2, negative 5, and 2, negative 3. Okay, and we know it should be like this, but on its side, so it ends up looking like this. And the question was, sketch the inverse. Is the inverse a function? Not a function. Is the inverse a function? No, it is not. Why is it not a function? It doesn't pass the vertical line test. Why or why not? Didn't pass the vertical line test. All right, that's it. So that is why technically and I'm sure hoping some of you noticed it from the beginning, from the get-go, should I even have done all this work? No, because the original function is a function, but it's not a one-to-one function. So because it's not a one-to-one function, the inverse does not exist. This inverse does not exist because the inverse is not a function. The inverse of a function still needs to be a function. So we could cut off half of it, and that would work. Or we can cut off that half and that half, and that would work. But we can't take it, the inverse of a full parabola does not, a full parabola function does not have an inverse. All right, next one, I'm running out of space. I'm gonna try to make it a little bit smaller. X, f of x, 1, 2, 1, 2, 3, 4, 0. Nope, I'm not going to do that one. That's actually not a point. They give you the dark points. And you will have one like this actually on the test. Okay, so that's negative 2, 4. This point right here is 2, 1. And this last point over here is 1, 2, 3, 4, 5, 6, 2. Again, that was negative 2, negative 4, 2, 1, and 6, 2. 1, 2, 3, 4, 5, 6, up 2. All right, so if I can squeeze it in here, this is going to be my f inverse function, negative 4, negative 2, 1, positive 2, and 2, 6. And then you're going to go through and plot those points. I'm going to go ahead and draw my y equals x line. And again, you will have one like this on the test. Please do not ask me, how do I draw my inverse? You do this, make your t-chart, flip your t-chart, and plot those flipped numbers. That'll be your inverse. Negative 4, negative 2, 1, 2, and connect, and then 2, 6. And I'm going to fix that one because I put it on the negative side. Yeah. Okay. So, apologies, negative 4, 2, 1, 2, 3, 4, negative 2, positive 1, 2, and then 2, 6. And you can see that they are a mirror image across this line, y equals x. All right. We will do this one together in class. You can try it on your own and then come back and check in with me in class. That's it for this lesson.